Alright, so today we're going to do the exact same thing as yesterday, except today's going to be in radians. So just a really quick review of our radians. Pi over 6 is used for 30 degrees. If you converted pi over 6, you would find that it's 30 degrees. Pi over 3 is 60 degrees, and pi over 4 is 45 degrees. And then the rest of this is just the same thing that we talked about yesterday, but in radians. So, I mean, this is good and fine if you know this, but the easier thing to do is to draw that picture where we say cosine, brother secant, so cosine inverse, secant inverse, all lie on a cot, so cotangent inverse. And when you draw the picture of the cot, you have this flat surface with your big belly up. So that starts at 0 degrees, and in radians it goes to pi, so 0 to pi, which if you notice, that's what this says. And then the other ones, so you gotta, this thing is what you memorize, and then you just kind of know, well, the other ones must be the other way. So that's sine inverse, cosecant inverse, and tangent inverse. So this is this direction, and so this is 0 degrees, which means you go down, or in the opposite direction. This is negative pi over 2, and this is positive pi over 2. All right, so let's go ahead and start this. If we want to find the exact principal value in radians without using a calculator, so x equals sine inverse negative root 3 over 2. So this is a ratio of sine that's negative. So we say cosine secant lie on a cot. This is not cosine secant or cot, cotangent. So I'm going to draw this picture where I would put it in quadrant 1 if it was positive and quadrant 4 if it's negative. So since I do see a negative ratio right here, I'm going to draw a quadrant 4. And that quadrant 4 has an opposite that's negative root 3. I know it's negative because it's going down, and a hypotenuse of 2. And if this is a root 3 and this is a 2, I know that I could finish out my triangle with a 1 here. But what's really important is that across the root 3, this is called your reference angle. That would be 60 degrees. But that's degrees. Our goal today is to do radians. So let me erase that. Remember that 60 degrees is pi over 3. Really the best thing to do there is just to memorize those radian, which ones go with which. So I'm talking about this up here. I would really probably just memorize which one's which. Because in your head, you're probably thinking 60, but when you answer in radians, you need to say pi over 3. So if this is pi over 3, that's called the reference angle. But your final answer is to say, well, if you start at the 0, I'm going to go pi over 3 in the opposite direction. So that's negative because you went in the clockwise direction, pi over 3. That's your answer. So it's the exact same concept as yesterday, it's just that we're doing radians today. So arc tangent, root 3 over 3. So if we see arc tangent, root 3 over 3, hopefully what you're thinking about right now is this is not a ratio that you know. Since you see the root 3, then you know it's going to be a 30, 60, 90, and you have 1, root 3, and 2. So this is the rationalized version of which one of these things. So it's either going to be 2 over root 3 or 1 over root 3. Which one of those, if you rationalize, do you get this? So it is going to be the 1 over the root 3. So tan inverse of 1 over root 3. All right, so this is a positive. When it's a positive ratio, you can automatically draw 1. You don't even have to go through the saying. All positive ratios go in quadrant 1. And this is tangent, which is OA. So my opposite is 1. And my adjacent is root 3. So this must be 2. And across 1 is 30 degrees. 30 degrees in radians is pi over 6. And since I'm in quadrant 1, your answer is your answer, so pi over 6 is final. All right, so if we do x equals cosecant inverse of negative root 2 over 1, so if we say cosine brother secant lie on a cot, this is not cosine, this is not brother secant, this is not cotangent. Therefore, I'm in quadrant 1 and 4. Quadrant 1 would be for positives, and quadrant 4 would be for negatives. So since this is indeed a negative ratio, I'm in quadrant 4. So in quadrant 4, I need to draw a triangle whose hypotenuse is root 2 and opposite is 1. So if you have an opposite of 1 and a hypotenuse of root 2, it does make sense that this would be a negative ratio because I'd actually have to go down 1 for the opposite. So this is a 45, 45, 90. Which makes this 45 degrees, but in radians, 45 is pi over 4. And then because I went in the negative direction, this is actually negative pi over 4. All right, so let's do some more examples. So tan inverse negative 1 over root 3. Cosine brother secant lie on a cot. It's none of those, so I must be in quadrant 4 again. And tangent is O over A, so my opposite is 1. My adjacent is root 3. One of these guys is supposed to be negative because I see a negative ratio here. So this is to the right, that's positive, but this is down. So I'm going to put a negative sign right there. And this would be 1 root 3 and 2 is how I finish this triangle, which makes this 30 degrees. In degrees, it's 30, but in radians, that's pi over 6. And in that negative direction will be negative pi over 6. All right, let's do tan inverse of negative 1. So this is which quadrant? So cosine, secant, cot, it's none of those. So I must be in quadrant 4. And I can go ahead and put this over 1. So opposite over adjacent. So 1 is one of those kind of can be tricky numbers because sometimes 1 will land you on the axis, but sometimes 1 will not land you on the axis. So really think about this before you dive into it. Can you have an opposite side of 1 and an adjacent side of 1? So on a triangle, can the two legs be equal? And the answer to that is yes, they can if it's an isosceles. And for us, 45, 45, 90 makes isosceles. This would be 1, 1, root 2. It does make sense that this is negative because I would have had to go down. So this is 45, 45, 90, so that's negative pi over 4. Okay, let's skip to the harder ones. Let's go to number 7. So cosecant inverse of negative root 2 over 2. So I say this is harder because root 2 over 2 is not a ratio that you should recognize. Or maybe you do recognize it by now, but it's because root 2 over 2, if your options are 1, 1, and root 2, the only way to get root 2 over 2 is if you had 1 over root 2 and you rationalized it. So think about that for a minute. This rationalized is this. So once upon a time, this used to be cosecant inverse of negative 1 over root 2. All right, so cosecant inverse when it's negative is in quadrant 4. And this is another negative pi over 4. Okay, number 8, arc cosine of 1. So, cosine secant lie on a cot. This is cosine inverse. So it really doesn't matter though, because this is a positive number, so I'm going to draw quadrant 1. Anytime it's positive, you're in quadrant 1. Now again, 1 is a hard number sometimes, because sometimes you can't draw the triangle. Let's think about this one. If you put 1 over 1, your adjacent is 1 and your hypotenuse is 1. Now think about any type of right triangle. It's got to be a right triangle if we're talking about the hypotenuse. Can the hypotenuse be the same length as a leg of a right triangle? So we know that the hypotenuse is always longer. So this is our first real big indication that there's no way that this is going to be a triangle. It is impossible. So that's our first indication that we're either going to be here or here. Now, one of these points represents an adjacent movement. One of these points represents an opposite movement. With respect to the origin, which one represents the adjacent movement? So adjacent means side to side. So this represents the adjacent movement. So this is our answer, and that is 0 degrees or 0 pi or just 0. If you want to write 0 pi, that's fine. All right, cosecant inverse. I'm on number 9. Cosecant inverse of -1. I'll put that over 1. And since this is cosecant, let's see, it's cosine and secant lie on a cot. So this is not lying on a cot, so I must be in quadrant 4. And cosecant is h over o. So once again, you see that the hypotenuse is supposed to be 1, same time that the opposite is supposed to be 1, which is, again, not a triangle. So we're either going to be here or here. Now, since one of these guys is supposed to have, we would never say that the hypotenuse would be negative. So really you should be thinking about 1 over -1. So this opposite is supposed to be -1. Opposite is your up to downness, so that's got to be here. So this is our answer. And from the 0 you went 90 in the other direction, so that's negative pi over 2. Pi over 2 is 90. Oops. All right, let's go to example 10. X equals sine inverse of 0. So, cosine secant lie on a cot. This is not cosine secant or cot, so I would be in quadrant 1 or 4. Quadrant 1 if it was positive and 4 if it was negative. Well, there's one indication. Where do you put 0 on a number line? In the positives or in the negatives? Really, neither one of those, right? So that's kind of your first indication of where the answer is going to be. But if you want to go ahead and check it, which you probably should, if you think about this right here, does this represent an opposite of 0? Because it should, right? Your opposite should be 0. But yeah, right here it does, because your opposite is your up to downness. There's no up to downness. From the origin, you just went to the side. So yes, this does. So this is our answer at 0 pi. Okay. I really think that's good enough for today.